So I'm going to give you kind of an abbreviated version of section 12.4. The one big thing that you should get out of this when it's all said and done is the ability to solve a system of equations using an inverse matrix. Now it's going to take a little bit of finesse and skill with the calculator, but once we get that skill, you'll be able to solve a 2 by 2, a 3 by 3, a 4 by 4, a 5 by 5 system of equations in like a minute. It's just going to be just a matter of pushing in a few buttons and you'll be done. So it's worth the effort, and that effort starts with understanding what's called an augmented matrix. So to start bridging the gap between what we would write down on our pens and paper and what you can put in a graphing calculator, we need to start looking at the coefficients. So the coefficients of this one would be 2, -7, -5, 8, 9, and 17. Now typically speaking, when people write these things, they're going to put a line between the last two columns because that separates the left-hand side, your coefficients, from the right-hand side, which are just your constants in this term, constants in the system of equations. And that's it. That's your augmented matrix. But this is something you can put into a graphing calculator. So that's where we want to go. Now, this is my own example. Let's take a quick look at problem number 14. X plus y plus z equals 4. 2x plus y minus z equals 1. And 2x minus 3y equals 1. And I want you to write down the augmented matrix for this. So what's that going to look like? Okay, Micaiah, what's that going to look like here? What's the first row going to be, please? Good. Second one? And I'm most curious about the last one. What's the last one going to look like? Perfect. 2, -3, 0. Even though there's nothing there, we have to still account for the z's. And that's going to mean a 0 for the z's there. Cool. Thank you so much. Let's try one that goes kind of in the opposite direction. Problem number 16 is going to start out with the augmented matrix, and I want you to write the corresponding system of equations. So the augmented matrix is 1, -2, and 9, and then a 1, 0, 1, 4, and 0, 0, 0, 1, and -7. So let's put in that little line here just for our convenience. Like that. And you need to write down the corresponding system of equations. Rachel, what's that going to look like for us, please? Good? Cool. We agree with that? Now there's something nice about this system of equations. And the one nice thing for sure is that we already know what z is, right? z is -7. So if I wanted to figure out some of the rest of this stuff, I can take this value from -7 and plug it into here. So let's do that. Let's actually finish solving here all the way. That's going to be y plus 4 times -7 equals 0. Okay. So that's y minus 28 equals 0, or y equals 28. Great. 2 down, 1 to go. If y equals 28 and z equals -7, how am I going to find x? Perfect. Yeah. Go up to the first equation, because it's the only one that has an x in it, and plug them in. So x minus 2 times 28 minus 9, or plus 9 times -7 equals 1. So x minus 56 minus 63 equals 1. So that's x minus 119 equals 1, and x equals an even $1.20. Yay. So this worked out really nice. And the reason it worked out really nice is because of the form of this augmented matrix. You had this upper triangular form, meaning everything below this main diagonal was 0. So that's great. Now, it's not something we're going to try and stress in this course, is to put matrices in that form. But you can do that by the kind of steps that we're doing when we're solving systems of equations by the addition method. You can multiply a row by something. You can add a multiple of one row to another row, etc. You can switch the order of rows. And they give you kind of a little bit of a glimpse of that in some of the problems. It's a process called Gauss-Jordan elimination. So you're going to start out with a system of equations like this. Then you write it as an augmented matrix. And then you start playing with things to try and get that augmented matrix in the same form that we had. So you could in exchange row 1 and row 3. And then you could start getting zeros here and here. If I multiply the top row by -2 and add it to this row, I'll get a 0 there. -3 times the first row added to this row gives me a 0 there. And that's exactly what they did. If you go a little bit further, you can get it in that nice upper triangular form. In fact, at this point, you can see 24z equals 48, so z equals 2. And then this thing starts to unravel. That's nice. That's great if you can solve it that way. I'm going to show you a different shortcut. And that shortcut's going to involve plugging these things into your graphing calculator. Let me give you an idea of what's going to go on first before we do that. I'm going to start out with a very simple equation. 7x equals 21. Now, I'm sure 99% of you have already solved this in your heads, right? X equals 3. But instead of dividing by 7, let me show you a slightly different way. What if I multiplied both sides by the reciprocal of 7, or in other words, the inverse of 7? I still get what I want. 1/7 of 21 is 3. But on the left-hand side, what I want you to see is you're multiplying something by its inverse, or by its reciprocal. Let's think of it as the inverse of 7. 1/7 times 7 gives me a 1. So 1 times x is just x. I got my solution. Wow, that seemed like a painful amount of work to solve a really simple linear equation. The reason I did that is because I want to show you what we're going to do in general for a matrix system of equations. So we're going to start replacing this and this by an entire matrix. So I'm going to write my system of equations like this. Let me grab an example. Let's take a look at problem number 32 here. 2x plus y minus 3z equals negative 1. 3x minus 2y minus z equals negative 5. And x minus 3y minus 2z equals negative 12. My goal is to rewrite this using matrices and then solve it using matrices. So to do that, I'm going to let A be the matrix of coefficients. So that's going to be 2, 1, negative 3. 3, negative 2, negative 1, 1, negative 3, and negative 2. I'm going to let capital X, let me maybe write it like a Roman numeral 10, is my variables, x, y, and z. And then matrix B is going to be this right-hand side, negative 1, negative 5, and negative 12. With this, I can rewrite this system of equations like this. AX equals B. So this is equivalent to this. They're interchangeable. The nice thing is that this is getting closer to something your calculator can work with. Now, how do we solve here? Over here, I multiplied by the inverse of this. I can do the same thing here. It might not even be worth your effort to copy down the next two lines, but this is very technically what's happening. I'm going to multiply both sides on the left by the inverse of A. Now that's something that our calculator is going to give us. And thinking too much ahead, that's going to be a B here. Now, what happens when you multiply something by its reciprocal or its inverse? You get 1. And I'm not even going to write that 1. Let's just get rid of that. And here's our solution. A inverse times B. And that's what your job's going to be, is to plug in matrix A, hit the right buttons to get A inverse times B. Actually, you need to plug in A and B. But that's where we're going to go. This is the solution, is x equals A inverse times B. So let's work on plugging those in and calculating those. We're going to need to plug in matrix A and matrix B. So let's do that here, do it together. So I'll just clear out this stuff. Remember where to find the matrix stuff, right? Second, and then x inverse. We want to edit this, so I'll cursor to the left. Matrix A is a 3 by 3 matrix, and if you want to follow along with me, I'll go across the top, first row, second row, and then third row. So it's going to be 2, 1, negative 3. Make sure you use the negative on the bottom row of the calculator, not the subtraction sign. Then 3, negative 2, negative 1. And then for the last row, 1, negative 3, and negative 2. That's our matrix A. How do we exit this? Good. Second mode to quit. If you wanted to look at that matrix and make sure you typed it in correctly, you can hit the second key, then the matrix button, press enter twice, and it should print out matrix A for you if you wanted to take a look back at that. Make sure, did I enter that right? Yes. we did. All right, we need to take A inverse times B. We haven't entered matrix B yet, so second matrix, go over to edit first, and then down to matrix B. Now, matrix B is a 3 by 1 matrix. It is 3 rows, 1 column. So let's enter those values. Matrix B should be -1. One second. -1, -5, and -12. All right, so one more time to get to that matrix B, you hit the second key, the matrix button, go over to edit first, and then cursor down, or you can just type the number 2 either way to get to B. Then if you cursor down, press enter. So the values in matrix B should be -1, -5, and -12. Are we good there? Yeah, okay. All right, let's exit this. Second button, and then quit. I need to type in A inverse times B. That's what I'm looking to calculate. So to get A inverse times B, this part right here, we first need to type the matrix A. So let's do that. Second matrix, press enter. And then I'm going to hit the inverse button. So that's A inverse. Now I want to multiply it by B. Well, I don't need to hit the times key. It's going to understand that if they're written next to each other, they'll be multiplied. Second matrix, and this time press the number 2. So A inverse times B, press enter, you should get your solution. Go ahead. All right, so let me run through the calculations one last time. In fact, let's do... all right, so starting from scratch, second matrix, then press the number 1 or type enter. Then hit the inverse key. And then we have to do the same thing for matrix to get matrix B. Second X inverse, this time type the number 2, then press enter. All right, you might have accidentally entered in a number wrong in your matrices, but if you got A inverse times B, that's the right command. So we'll just have to check you got everything entered. Are we okay? Did that work out for you guys, that you got the correct solution? So what this is saying is that X is 1, Y is 3, and Z is 2. So going back here, 1, 3, and 2, or better yet, 1, 3, 2. Yay. So once you get the commands down, boy, these things are really fast. And it doesn't matter if you're solving a 2 by 2, a 3 by 3, 4 by 4. You can do it for anything. In fact, those of you taking chemistry, it's a really nice, easy way to balance your equations. When you start trying to figure out, well, how many molecules of this do I need to get the number of oxygen and hydrogen and carbon molecules to balance out? This is really, really cool. Now, let's practice this one more time with a 2 by 2. And then let me show you, we'll go back and take a look at something from our previous section to let you know that, well, things can go wrong, just like they did in section 12.5. So let's solve problem number 28. Now there's nothing wrong with solving problem number 28, kind of old school. So it's 5x minus 4y equals 10. And x minus 7y equals 2. I mean, it almost feels like overkill to use the inverse matrix on a problem like this, but we're doing it for the practice. I'm going to stay here and just do it on my graphing calculator this way. First thing I need to do is I need to enter in a new matrix A and a new matrix B. Can anyone tell me what matrix A is going to be for this one? Good. So 5, -4, 1, -7. Demetrius, how about matrix B? What do you think that's going to have? Thank you. 10 and 2. So let's enter both of those into our matrices. So hit the second key, then the matrix key. Go over to edit. You want a 2 by 2 matrix, and I've already got mine entered in. 5, -4, 1, and -7. When you're done with that, you hit the second button, then the mode key to exit. Then you've got to enter in matrix B. Second matrix. Cursor to the edit button first, and then select matrix B. Matrix B has 2 rows, 1 column. Go down here, and it's 10 and 2. Once those are entered in, you quit. If you want to look at them, you can. Just type second, then matrix. Then type the number 1 or number 2, depending on what you want to see. But that's a double check that we got both of them in there correctly. Last but not least, I need A inverse times B. So matrix A, inverse button. So right here, our inverse button, x to the negative first power, times matrix B. Second matrix, A inverse B. So our solution is 2 and 0. And that corresponds to x and y. Or better yet, 2, 0. So to edit B, you hit the second button and the matrix button. Cursor to the left once to get to the edit menu. Go down 1, or type the number 2 either way. Type the number 2 or go down 1 and press enter. Then type in the number 2 over the number 3, so just type right over it. So if yours said 3, 1, then just go back and type in a 2, and then a 1, and then type in the values that you need, 10 and 2. All right, I want to look at one last problem here for us, and it's up to you if you want to program this in or not to follow me along. Might not be a bad idea. It's one that we did in section 12.5, so hopefully we're a little bit familiar with it. It's that problem number 48. Are we okay with 28 before I move on to 48?
How'd you get it? Like, after you get B, you just showed me. How do I get to 0?
You have to type in A inverse times B. Mimi? Okay. No, can you help Greg? Get him to get A inverse times B. Okay, so 5x minus 4y equals 20, and 10x minus 8y equals 30. So that's problem 48 from section 12.5. Do you remember what was going on with this one? We talked about it in detail for a little bit. Yeah, they're parallel lines. I mean, it almost looks like if you double this one, you get this one, but not quite. The right-hand side doesn't quite match. So if you double this, we don't get it. These are parallel lines. Now, when we were working with this earlier, we calculated D, the determinant matrix of coefficients, to try and do this with Cramer's rule. We found that the determinant was 0. And we knew right then we had a problem. Well, what's going to be your signal or your clue when you have this and you're trying to do it with an inverse matrix? Well, let's find out. Let's enter in A, so second matrix, and I'll go over to edit. Let's enter in A. What's going to go in A? Kendrick? For this one, what do you think would be A? So 5, -4, 10, and -8. Good, thank you. Second, quit. I want to get out of there, and I want to put in B. So second, and then matrix. Now let's put in B. So you want to go over to the edit button first, and then drop down to B. It's still a 2 by 1. This time it's 20 and 30. Second, quit to get out of there. Last but not least, I need to type in A inverse B. Second matrix, A, -1. Second matrix, B. So there's my A inverse B. And I'm ready for my solution. Oh, wait a minute. Something's wrong. And what's wrong is that you can't find the inverse here. And the short story is this. If the determinant is 0, you can't find the inverse of a matrix. They don't exist. You have what's called a singular matrix. So if D equals 0, then A -1 does not exist. You can't find the inverse. So A is a singular matrix. Yay. So you can't do anything with it. So if you get that error, you didn't do anything wrong. It just means that the determinant is 0. You can't find the inverse here. You're going to have to figure out, well, what's going wrong? Is it that the lines are parallel? Or is it that the lines are really one right on top of the other? One of those two is going to be the case, and you're just going to have to figure out which one it is. Any comments or thoughts on doing things with the inverse matrix? Let me give you some homework. Kind of a, what's that? 27th, I thought. We're not quite up with the schedule. So for homework, try 13 and 15, and then 25 through 37. Yeah, that's 12.4.